Welcome to Module 3, Lesson 4. Today we are going to talk about graphing functions and using graphs with functions. All right, so I'm going to make this the whole page here for you. So now again, you guys are on page 137 in your books. And we're going to start and go through each of these, and I will let you know what you're going to do on your own and then what I need you to work on and then come back. So just kind of pay attention here because it's going to be a slightly different schedule, so to speak. Okay, so first of all, I want you to remember that the domain of a function is the set of all of its input values or the x values. In this case, we're really going to try to remember that they're x values because remember in an ordered pair, so in an ordered pair you have x comma y. So in this case, your ordered pair is your input and your output. Right? So we're going to use those to help us graph these functions. So in this case, I have the equation x plus 3y equals 15. So we're working up here. Now the problem is, I usually like to have y all by itself, so that way I can say, since x is my input, when I put this into the function and use the function, what do I get out for y? So I know that in order to do that, I have to get y by itself by subtracting x from both sides. And I'm left with 3y equals 15 minus x. And then I have to divide both sides by 3. Okay, so this leaves me with, I know that I can do 15 divided by 3, which is 5. Oh, and actually, let's reverse this real quick. So the way this problem has it set up, it wants us to switch the order first because we want our x listed first. So remember, we can only use the commutative property when we have addition. So we need to change addition to subtraction. But in order to do that, I know that minus positive x is the same as adding a negative x. So I have to change that in here. So I have, this is the same thing as saying x, negative x plus, well, let's not change it right away. I want you to see that this is the same as saying 15 plus a negative x. And then, because of the fact that it's addition, I can use the commutative property and say negative x goes first, 15 can go second. Then I divide both sides by 3. And here I end up with negative x over 3 plus 15 divided by 3. Now 15 can be divided by 3 and it gives me 5. However, I can't do x divided by 3, but what I can do is say negative 1/3 times x plus 5. So these two pieces right here are the same thing because it's like saying if I were to take 1/3 times x, I know that I'd multiply straight across and get x over 3. So usually we'll use that because it makes a little bit more sense when we start talking about linear equations. All right, so now that I have my function all set up, and I know that I have a domain in this case of 0, 3, 6, and 9 that's listed above. So I have a domain of 0, 3, 6, and 9. And so those are the only numbers that I can use as inputs, and I want to find my outputs. So what that means is when I put in 0, what do I get? So I have to actually do the math. So when I do negative 1/3 times 0, I get 0 plus 5 is 5. So in this case, when my input is 0, my output is 5. Now here I'm inputting 3. And I know that negative 1/3 times 3, okay, well remember those are reciprocals, so it's going to actually give me negative 1 plus 5 gives me 4. So in this case, when my input is 3, my output is 4. And then here, so I want you to go ahead and pause and try these two by yourself and see what you come up with. All right, so when you did this, you should have gotten that when you input 6, your output is 3. And then when your input is 9, your output is 2. Now, if you're confused to how that worked, the biggest part that I can say is 1, remember that these first numbers are negative that you're working with, and remember how you multiply fractions. So when I multiplied by 6, that was actually 6 over 1, which gave me 6 over 3, which was 2. So here I ended up with negative 2 plus 5, which is what gave me the 3. All right, so now I have all of my inputs and all of my outputs, and they're listed as ordered pairs. So remember, this is always your X and this is always your Y, and you have to, so think about it like when you're shooting a layup in basketball. You have to run down the court and then jump up to shoot the layup, or an airplane has to speed down the runway and then go up into the air. So in this case, you have to always start at the origin, which is 0, 0, and you have to go over and then up. Well, I'm going over 0, so I'm not moving, and then I'm going up 5. So let's look at our intervals here. So each of these is worth 2. So this is 6, so halfway between would have to be 5. Okay, now when I put in 3, so I go over 3, I go up 4. When I go over 6, I go up 3. And when I go over 9, I go up 2. Now, our first instinct is to make these into a line. However, we can't do that. And the reason being is because these numbers were our only inputs. If I connect this line, so if I draw a line here through this, that implies that everything in here in these sections of the graph are part of that domain and range, that each of these inputs and outputs are part of this function. Well, in this case, it's not, because our domain was only these numbers. So here, it includes 2, and you notice 2 is not part of our domain. So you cannot just draw a line. The only time you can draw a line is when you're given a different type of domain that we will talk about later on. Okay, but remember, if you're only given specific numbers to use, then you can only use those numbers and you can only plot those numbers. All right, so moving right along, this is actually going to lead right into our reflection and discussion. So again, why do you not connect the points on the graph? Because the numbers, the graph would include, were not a part of the given domain. So I can't graph things that I don't have information for. And in this case, they said we only want you to graph points for 0, 3, 6, and 9. So I can't graph and I can't connect the dots because then I would be graphing other pieces. But now if you look here, how would the graph be different if the domain was 0 is less than or equal to x, which is less than or equal to 9? Well, now you have to think of what this actually means. So this means that any number, oops, that should be a y, any number from 0 to 9 can be a part of the graph. That includes any fraction, any decimal, it includes 2, 3, 4. So when it includes all of these numbers, that's when you're looking at a graph with a line. So if I add this line, and now actually it can't go past 0, and it can't go past 9. So it's saying that any of these little numbers that are in here are all part of your domain. So instead of listing all of them and then making dots for all of them, that's when the line comes into play. So our graph would have a line, or would be a line, in order to include everything. All possible domain values. So again, when you're given a specific domain, you can only plot those points. But when you're given an inequality, that tells you that everything between those two numbers is in play. So that's when you're absolutely going to have a line, because you cannot make all those dots. All right, moving right along to the next problem. We have graphing functions using a domain of all real numbers. So this is basically what we just did before. So here we have the function f of x is equal to 3x minus 5. Okay. So now, and I'm sorry, I forgot to mention that I skipped over A so we could do B together. All right, so now the first one already has an input for us. So here's our function. And it already put an input for us. So f of negative 1, so 3 times negative 1 is negative 4, minus 5, I'm sorry, is negative 3. 3 times negative 1 is negative 3, minus 5 is negative 8. My goodness. Okay, and then now, so here it tells us that our input is 0, so f of 0, so I'm substituting 0 for x. I have 3 times 0 is 0, minus 5 is negative 5. So when we have an input of 0, I get negative 5 as my output. If you feel comfortable, go ahead and pause and solve the rest of these on your own, and then come back and check your work. All right, so here if I input 1, because these are my inputs, then I get 3 times 1 is 3, minus 5 is negative 2. So when I input 1, I get an output of negative 2. Here my input is 2. I know 3 times 2 gives me 6, minus 5 is equal to 1. So when I have an x value or a domain of 2, I get a range of 1. When my input is 3, 3 times 3 is 9, minus 5 is 4. So when my input is 3, my output is 4. And here f of 4, 3 times 4 is 12, minus 5 is 7. So when I put in 4, my output is 7. Okay, so in this case, I was given a list of inputs and outputs to use. However, we're graphing all the real numbers. So remember, we're graphing a domain of all real numbers. So the first thing we have to do is we have to pick inputs. Okay, you can choose your inputs in order to create your pattern. In this case, we chose negative 1 through 4. Make sure, don't use crazy numbers, because then you're going to end up with stuff that's going to go off your graph, and it's just going to make life more complicated for you. Right? So the points appear to form a what? So if I go through and I plot my points, so I have negative 1, so backwards 1, and then negative 8, which is down, so here. And then I have 0, negative 5. And then I have 1, negative 2. 2, positive 1. 3, positive 4. And 4, positive 7. So when I look at this, I notice that all the lines, or all the dots, appear to make a line. Okay, so I put that on there, so all my points appear to form a line. So I'm going to draw a line through all the points to show ordered pairs that satisfy the function. So I'm going to draw my line, and I'm going to actually use a line tool here in order to make it look a little bit nicer. And then at the end of each line, I have to put arrows because I'm graphing a domain of all real numbers. What that means is any number inside of this graph, so actually any number, any possible number that is a real number can be put in and be a part of our graph, be a part of our problem. So I have to graph it as a line and show that it continues to go on forever because of the fact that I have infinitely many choices. Okay, because I have infinitely many choices, I have infinitely many solutions. And that's why we put the line in here to show that we are able, that these are part of the graph. Okay, so it's kind of like your inequalities. When it's a closed dot, it's a part of the solution set, and when it's an open dot, it's not. So in this case, when you have you can only use a line when the number is part of the domain, and you can only use points when it's specific domains. All right, so you're going to go ahead and do these your turn problems on your own, and we'll go over them when you come to class tomorrow. Right? In this case, because you're graphing, you are not going to be submitting your answers online, and you do not need to worry about the reflection question for number 3. Right? But we are going to go ahead and turn to page 140. So don't forget to go back to page 139 to finish those problems. And now we're going to look at when we're graphing using values. So in this case, we're going to use a graph to find the value of f of x when x is equal to -2. All right, so to find the value of a function for a given value of x using the graph, locate the value of x on the x-axis, move up and down to find your spot. So really this is just saying, how do you read a graph? Right, so first of all, we want to first graph the line. So first we have to locate -2 because that's what we're looking for. First we have to locate -2 on the x-axis. Okay? And then what's going to happen is I'm going to draw a vertical line segment from -2 on the x-axis to the graph of the function, and a horizontal line segment from the graph of the function to the y-axis. So basically, I'm saying, okay, well, here's -2. Oops, sorry, here's -2. When I go up and hit the function and go over, what do I get over here? All right, so let's start by graphing the function. So in this case, my function is 3/2 x minus 4. And let's just start putting in some points. So if I have 0, so f of 0, put in 0. And I know that this is 0 minus 4. So when I put in 0, I get -4. So 0, -4. Let's see, what if I put in 1, I'm going to end up having to do some fraction work here. So let's put in numbers that are going to work nicely with this. If I put in, let's say, so anything that can be divided easily by 2. So let's say I put in 2. So 3/2 times 2, which is going to be over 1 minus 4. So this gives me 3/1 minus 4, which is 3 minus 1, which is -1. So when x is 2, I get -1. All right, let's jump up a little bit further here then. Okay, instead of now saying, okay, well, let's do when it's 2. Let's try to go a little bit further ahead, and let's try, how about 4? So f of 4 means 3/2 times 4/1, not equals, minus 4. So these two cancel each other out, and I get 1. They don't cancel each other out, but we can simplify. So I get 6/1 minus 4, which ends up being 2. So when I put in 4, I get 2. And actually, I went backwards on this. Hopefully you caught that before I did. When I put in a +1, I got a -2. And then here, when I put in a +4, I got a +2. All right, now I can go ahead and I can actually make my line, but I want to be careful because I want to know when it's -2, what do I get? Right? So I might want to extend it back this way a little bit more just to make sure that I have my points in the right place. Because if I draw my line incorrectly, I'm going to end up with an incorrect answer. So let's put in a negative option here. So let's go with -4. So I have 3 over 2 times -4 over 1 minus 4. I end up with, even if I did it this way, -12 over 2 minus 4. This is -6 minus 4. So this would actually be -10. So when I put in -4, I get -10 on my graph. Now you really want to make sure that you're using your straight edge to make your graph, because if you don't, your stuff isn't going to line up correctly and you're going to come up with an incorrect answer. So now I find -2, so -2 is right here, and I go down the graph, and now that I've hit the graph, I go over to the side, and I know my pen is a little bit off, so I apologize. So that's about halfway between 6 and 8. So I would say the value of y is the value of the y value in the function. Therefore, the value of f of x is -7 when x is -2. So again, you have to, one, do your graph. So choose points, make your graph. So one, I should say choose points. Graph, and then solve. Again, here's number 6. That is on page 140. You are going to do that one on your own, and we'll go over it when you come back to class. All right, last but not least, here we go. So we're going to model using a function graph. So really what we're going through here is how do you create these graphs and how do you use these graphs, right? So the domain of a real-world situation may have to be limited in order to have reasonable answers. Only non-negative numbers can be used to represent quantities such as time, distance, and the number of people, right? So you can't have, what it's saying is you can't have negative time, negative distance, or negative people. Right? When both the domain and the range of a function are limited to non-negative values, the function is graphed only in quadrant 1. So there's no possible way to have the graph in any other quadrant because you don't have the possibility of your answer going negative. So in this case, when we had those negative answers, we had those negative inputs and all this down here, whoops, put that back for you. That couldn't happen because of the fact that we can't have negative values, right? So it can happen with other stuff, but in terms of real life, things like that can't have negative values, so you can't have that downward slope or downward into the other quadrants. All right, so the Mid-Atlantic Ridge separates the North and South American plates from the Eurasian and African plates. The function y equals 2.5x relates the number of centimeters y the Mid-Atlantic Ridge spreads after X years. So it's saying that this is how far it splits after this many years. Right? Graph the function and use the graph to estimate how many centimeters the Mid-Atlantic Ridge spreads in 4.5 years. So first we're going to analyze the information and we're going to look at the important information. So the function of, and we're just looking at exactly what the function is in this case. So the function of y equals 2.5 times x describes how many centimeters the Mid-Atlantic Ridge spreads after X amount of years. Again, that's what we stated up above. So that function tells me in this many years, it spreads this much. Okay? So in this case, I can only use non-negative values for x and y because years can't be negative. So I can only use non-negative negative. And I can't say positive values because you can use 0, but 0 isn't positive or negative. So I have to use non-negative values of x and y. And then I'm going to use a graph to find the value, excuse me, of y when x is, well, in this case, I want to know 4.5 years. So when x is 4.5, I want to know what is y. So when I've gone 4.5 years, or when time has gone on for 4.5 years, that'll tell, putting it into that function will tell me how many centimeters it's spread. All right, now I can't just plot one point, because if I only plot one point, I can't see the trend, I can't see the pattern, and I can't then use the graph because I can't follow up from 4.5 to anything. I can't just choose a random spot on my graph and say, oh, okay, when I have 4.5, I get 10. That doesn't work. You have to have a pattern that you found, and you have to graph it, and then use that graph to find your answers. All right, so again, you can pause and go through these on your own. When you come back, I'm just going to put in the answers for you to check. All right. Again, to make sure that your answers make sense, in 0 years, it should move 0 centimeters. So if you didn't get that here, you definitely want to make sure you're double checking that work. Okay, so first we're going to plot the points that represent the ordered pairs on the graph. So we have 0, 0. And then we have 2 and 5. And then 4 and 10. And 5 and 12 and a half. Right? Now, those are sometimes a little bit difficult to plot because of the fact that you have two numbers between 12 and 14. So I've actually plotted that closer to 13, so I'm going to try to make it a little bit lower here. Oops. There we go. So you really want to make sure when you have numbers that are on actual grid lines that you're given, make sure you plot them correctly because you really need to have an accurate graph in order to get the correct information. Okay, and now I can, since I've plotted my points, I can draw my line. So I'm going to draw a line through all the points because the points appear to form a pattern. Okay, they appear to form a pattern because of the fact that they go in a line and that pattern is a line. Now, if the pattern was like this, that might not necessarily work. So you really want that pattern to be a line. Okay, then we're going to use the graph to estimate the y value when x is 4.5. Right, so again, I'm going to follow it up from 4.5. So 4.5, so here's 5, so 4.5 is about right here. I follow 4.5 up. And then I follow it over here. All right, so it looks like to me that when 4.5 years go by, it looks like it might be 11. However, you have to look and see that it is a little bit higher than 11. So the answer here is that the Mid-Atlantic Ridge spreads about 11 and 25 hundredths centimeters in 4.5 years. Now, here's the deal. When you're given stuff like this, I don't like these examples. However, we have to work with what we're given. When it's in between like that, you have to give it your best bet. If you had said 11, I would have, as a guess, I would have said, okay, that does look good. But then you definitely want to go back and check your answer. So in this case, if I had gone back and put 4.5 in, then I know that I wouldn't have just gotten 11 out. Not to mention, if I have 4 right here, and I know that when I put in just 4, that I got 10. Well, now I'm going an extra half of a year, so in theory, it should go another, so it should spread half as much as that. So you have to kind of look at how the relationships are working, But know that when we work on these things and when we work on problems, the graphs that I'm going to give you to work through, I want to make sure that you're understanding it, so they're going to be a little bit easier to get through. All right, so the distance of the Mid-Atlantic Ridge spread increases as the number of years increases. So the gap gets bigger as the years go up. So the graph is reasonable. So if all of a sudden, I had gone from 40 years having 10 centimeters of movement to 4.5 years and having 5 centimeters of movement, then I know that I would have done something incorrectly. All right? So when x is between 4 and 5, y, sorry about that. Oops, well, when x is between 4 and 5, y is between 10 and 12 and a half. Since 4.5 is between 4 and 5, and it is reasonable to estimate y to be 11 and 25/100. Okay, so again, since 4.5 is halfway between 4 and 5, you want to look at what's halfway between, or think about what's halfway between 12 and a half. All right? So again, we're using a little bit more reasoning in this as well. All right, so you do have one more set of U-tries. So you have the number 7. And then I also want you to go through and do your elaborate questions. I want you to do your best and make sure you're writing in complete sentences. And we will definitely go over those when you come back for class.